Dear students, I, Dr. Y. S. Dangi, going to present you a lecture on geometry of aerial photograph. First of all, let us start with introduction. Aerial photography records the ever changing cultural and natural features on the earth's surface. It shows geographical and physical and cultural features such as mountains, canyons, flatlands, rivers from the source to the mouth, lakes, forest, residential and industrial areas, road and rail networks, etc. The term photogrammetry describes from the three words, namely photo means light, gram means drawing and metry means measurement, which means light, drawing and measurement. The output result is a map, drawings, measurements or a 3D model of some real world objects. Application of photogrammetry. The categorization of the photogrammetry is based on the camera location during the actual photography. Accordingly, we have aerial photogrammetry, terrestrial photogrammetry and space photogrammetry. Aerial photogrammetry. In this, the cameras are launched on a machine that flies aircraft and therefore takes pictures. These pictures are useful in generating the measurements. In this case, for the statistical comparisons, at least two photos of the same objects or surface are clicked. In aerial photogrammetry, the aircrafts fly over a piece of land pointed with a particular landmark. The camera speed is controlling accordingly to the speed of the plane. The height of the plane from the land is also defined. The stereo plotter, that is an instrument that allows an operator to view two photos at once in a stereo view, processes the photographs. The photographs are also useful in automation processing for digital elevation model, that is DEM creation. Terrestrial photogrammetry. In this, the camera is usable in a stationary position and hence photographs need to capture from a fixed known position on or near the ground. The camera tilt and other specifications are in command. Phototheodolite is a unique instrument that utilizes in exploring the photographs. Space photogrammetry. This adapts all the aspects of extraterrestrial photography as well as measurements wherein the camera is non-moving on the earth or placed on artificial satellite or in the space. In general, the photogrammetry has many applications such as map making, urban and rural planning, environmental impact studies, civil law cases, real estate evaluations and even wall art. Geometry of aerial photograph. The quantitative analysis like measurements of linear distances, angles and height differences of the objects on the terrain as well as preparation of base maps. An aerial photograph is a central or perspective projection where the bundles of perspective rays meet at a point of origin called perspective center. A map is an orthogonal projection where every point on the ground is projected vertically onto the map on a reduced scale. One of the greatest advantage of central projection is its ability to produce a three-dimensional model of the terrain under the stereoscopes. In photogrammetry, there are three types of aerial photographs or imagery. These are classified on the basis of inclination of camera axis with the vertical or nadir points. They are as follows. Number 1, true vertical photography, which starts plus minus 0 degree from nadir. Nadir is a point just below the location of the object. Number 2, tilted or near vertical photography, which is greater than 0 degree centigrade, but less than plus minus 3 degree, and it is most commonly used. Third is oblique photography, which is between plus minus 35 degree and plus minus 55 degree of nadir. By vertical photograph or image, we mean an image taken with a camera that is looking down at the ground. As the aircraft moves, so does the camera, and this makes it impossible to take a true vertical image. Therefore, vertical image definition allows a few degrees deviation from the nadir, that is the line connecting the lens frontal point and the point on the ground that is exactly beneath the aircraft. In summary, a vertical image is an image that is either looking straight down to the ground or is looking a few degrees to either side of the aircraft. Now, we discuss on geometrical elements of the aerial photographs. Number 1, fiducial marks. Fiducial marks are the marks built into aerial cameras which appear on the sides or in the corners of the photo or both, and which are used to determine the precise location of the principal point. Number 2, fiducial axis. The lines joining the opposite fiducial marks on a photograph are called fiducial axis. Number 3, principal point. The principal point is the point where the perpendicular projected through the center of the lens intersects the photo image. Number 4, conjugate principal point. It is the principal point of an aerial photograph represented on an adjacent aerial photograph. Number 5, nadir point. The nadir point is the point vertically beneath the camera center or aircraft. Number 6, isocenter. The point on an air photo which lies halfway between the principal point and the nadir point. On a true vertical aerial photograph, all three of these would be at the same point. There is no such thing as a true vertical aerial photo. All air photos have some degree of tip or tilt. Number 7, swing. It is the angle measured in the plane of a photograph between the fiducial axis and the actual flight line. Airbase. It is a line joining two air stations or exposure stations. Photobase. The airbase is called photobase on aerial photograph, and it is the distance between the principal point of one photograph and the conjugate principal point of an adjacent photograph. Forward overlap or end lap. The amount of overlap between successive photos in a flight line to allow for stereo viewing, which is usually between 60 to 70%. Side lap or lateral overlap. The amount of overlap between air photos in adjacent flight lines, which is usually between 20 to 30%. Focal length. The distance from the optical center of the lens to the focal plane is focal length. Flying height or altitude. It is the vertical distance of aircraft above the datum, usually mean sea level, during flight. It is measured using an instrument called altimeter mounted in an aircraft. Tilt. It is the angle between the camera axis and the vertical or plumb line. It is also the angle between ground plane and photo plane. Tilt can be resolved into two components, one in direction of flight, that is the x axis, and the other perpendicular to the flight direction, that is the y axis. The point on the ground where a projected ray is perpendicular through the perspective center is called the ground nadir point, and the same point on the photo plane is called photo nadir point. The point at which the projected ray from ground to perspective center passes through the photo plane at right angle is called principal point. Tilt occurs due to unstable atmospheric conditions, human error of the pilot, or imperfections in the camera mounting, etc. Scale of aerial photograph. Scale is the relationship between distance on a map or photo and the actual ground distance. Scale is represented in two ways. Number 1, verbal scale, and number 2, representative fraction. The scale of aerial photo is determined by three methods. First, by establishing relation of a photo to ground. Representative fraction is equal to 1 divided by ratio of photo distance to ground distance. Second, by establishing relation of photo to ground with the help of map. RF of photo is equal to ratio of map distance to photo distance multiplied by RF of map. Third, by establishing relation between focal length of camera and the flying altitude. For flat terrain, RF of photo can be given by 1 divided by ratio of focal length to flying altitude. The scale of photographs is not uniform if there is irregular terrain. In tilted photo, scale is not constant. However, the change in scale due to relief is irregular and due to tilt of the camera axis is continuous. Two terms that are normally mentioned when discussing scale are large scale, example 1:25,000 cover small areas in greater detail. A large scale photo simply means that ground features are at a larger, more detailed size. The area of ground coverage that is seen on the photo is less than at smaller scales. Small scale. Smaller scale photos, that is 1:50,000, cover large areas in less detail. A small scale photo simply means that ground features are at a smaller, less detailed size. The area of ground coverage that is seen on a photo is greater than at larger scales. Overlap. Overlap is the amount by which one photograph includes the area covered by another photographs, as shown in the photograph shown on your screen, and is expressed as the percentage. The photo survey is designed to acquire 60% forward overlap, that is between photos along the same flight line, and 30% lateral overlap, that is between photos on adjacent flight lines. Stereoscopic coverage. The three-dimensional view that is called as true stereo vision, which results when two overlapping photos called as stereo pair are viewed using a stereoscope. Each photograph of the stereo pair provides a slightly different view of the same area, which the brain combines and interprets as a 3D view if placed in proper orientation. If aerial photo pair is kept in opposite orientation, then we get pseudo stereoscopic vision. In pseudo stereoscopic vision, we will be seeing inverse topography. It means that all positive relief features like hill ranges, escarpment and ridges, etc., look like negative relief features, valleys, ravines and depressions. Resolution. It is expressed in line pair per millimeter, that is number of lines and equal size gap can be resolved. We can get approximately 20 line pairs per millimeter on the original negative. If the original scale of the negative is 1:10,000, then the ground resolution will be 1 divided by 20 plus 20 multiplied by 10,000 mm, which is equal to 25 centimeter on the ground. Summary. Photogrammetry has numerous advantages which are as follows. Number 1, they covers large areas quickly. Number 2, photogrammetry technique is cost efficient. Number 3, the method is the easiest way to obtain or assess information from the air. Now, coming to applications of photogrammetry. To quickly verify the spatial positions of the ground objects, to prepare topographical maps, which are also called as surveying and mapping, helpful in military artificial intelligence, for the interpretation of geology or archaeology, analysis of crop damages due to floods or other natural disasters, to prepare a composite picture of ground objects, to relocate existing boundaries of properties, and helpful in the field of medicine. Finally, we can say that photogrammetry can generate a data set that will help many organizations or the stakeholders, therefore helping to create most efficient and effective plan for various projects. Thank you very much and have a nice day ahead.